Hey everybody, so we're back at it. This is the 2017 Mcas. What we're going to do is go problem by problem. These problems are in the older model of Mcas questions, but there's still a lot of value in it. So if you're watching this, hopefully you've already tried it. There's a PDF in the video description, and then you can go ahead and see how we did these. Now the answers are in the back, so you can always check them yourselves, but this will be kind of an opportunity for you to see how to solve these. All right, so let's start right to it. Now, this is in session one. And session one is non-calculator. So these questions you would not be using a calculator with them unless you have an accommodation to allow that. All right, let's see what's going on here. So it says, what is the value of the expression below? And we have the square root of 11 in parentheses brought to the fourth power. Let me zoom in here so you see a little better. So what I would recommend doing when you're solving a problem like this is to write it all out. And then again, the digital test you're going to be taking, you will be given a piece of scrap paper you can write on, or if you have dry erase markers, you can write right on the screen. So, okay, radical 11 brought to the fourth power is going to look something like this. Radical 11 times radical 11 times radical 11 times radical 11. All right, we're multiplying by here, 4 of them. And we know a square root times itself will give you the number inside the radical. So radical 11 times radical 11 is just 11. And then 11 times 11 is 121. Should be letter C. Okay. Number 12, we have what are the solutions of the equation below? So we have a quadratic equation here, and there's a few ways you could solve this. You could factor it and then solve it that way, or you could just plug these numbers in. So for many of you, you may forget how to factor, or you may have learned it not a long time ago. You may have learned it at the very end of Algebra 1 and you forgot, or maybe during COVID you didn't have the time you didn't get through all the content, which is very possible. But we all know how to plug things in and check. It takes a while to do it, but we're going to do it that way, okay? I'll also show you the factoring at the end, but we'll do it this way first. So we're going to plug these numbers in and see if they work. So both of these options have -6, both these options have -8, so we're going to be able to start eliminating some of these possibilities pretty quickly. So let's plug in -6. So -6 squared plus 4 parentheses -6 minus 12 equals 0. So -6 squared is 36, and then 4 times -6 is -24, minus 12 equals 0. 36 take away 24 is 12, minus 12. 12 take away 12 is 0. All right, so -6 works. So these two are possible. Let's plug in -2, see if it works. -2 squared plus 4 times -2 minus 12 equals 0. And -2 squared is 4, and 4 times -2 is -8, minus 12. This one's not going to work, you can tell. 4 take away is -4, minus 12, and that's going to be -16, so that does not work. Okay, so we can cross out A. Let's see if positive 2 works. So 2 squared plus 4 times 2 minus 12. This one's probably going to work, equals 0. 2 squared is going to be 4. Plus 4 times 2 is 8, minus 12 is 0, 4 plus 8 is 12, minus 12, 12 take away 12 is 0, so this one obviously works. So B is our answer. Now, let's say you weren't sure, you want to plug one of these in, let's plug in -8, because if -8 is false, we know these are both out, and that way we know we didn't make a mistake with this. I know when I took these tests when I was a kid, I would always kind of like want to go back and check, especially if I had unlimited time, or for all intents and purposes unlimited time, why not? So let's plug in -8 and make sure we didn't make a mistake here. So -8 squared. You'll notice that this negative sign's in the parentheses. It's really important. The only mistake a lot of people would make well, not only, but one of the common mistakes people would make on this problem is that they'd make a mistake with their order of operations when they solve this. So you'll notice when I'm plugging these are in parentheses when we're raising to the second power. That's very important when you have a negative integer. So -8 squared plus 4 times -8 minus 12 equals 0. -8 squared is going to be positive 64. 4 times -8 is going to be -32. Minus 12 equals 0. And 64 take away 32 is 32. Minus 12 equals 0. And then 32 take away 12 is going to be 20, and that does not equal 0, so that's out. So we know those are both out. Okay. Also, another opportunity for people to make mistakes on this is just knowing their times tables, because remember, or just knowing the order of operations too. But this is the non-calculator section, so students would need to know what 8 squared is, or 4 times 2, and things like that. And people do make mistakes, so just be careful if you see a problem like this. There are some order of operations problems on the new version of the Mcas, but they're a little different from that, which you'll see in the other videos that I've already posted. All right, number 13, the volume of a cube is 24 cubic inches. Which of the following estimates is closest to the length of each edge of the cube? So, all right, I like to draw cubes. Why not? Let's draw a picture here. No, that's kind of not a great cube, but it is what it is. So an edge is this. It's that little side here. That's an edge, that's an edge. These are all edges, okay? In a cube, they should all be the same, right? Which of the following estimates is close to the length of each edge? So we know the volume is 24 cubic inches, okay? We know the formula for the volume of a cube is going to be V equals S to the third power. S standing for the edge, the length of an edge. So we're looking for S. We're estimating that, okay? So we're going to set this equal to 24 cubic inches. So we're going to say S to the third power is equal to 24 cubic inches, okay? And in order to find S, we would need to take the cubic root, which is like the square root, but instead of a number that's multiplied by itself twice, it's going to be 3 times. So S would be equal to the cubic root of 24. So we're looking for a number that you multiply 3 times and get, well, 3 times and get the number 24. So they give us some estimations here because none of these are accurate because they're not in radical format because it's going to be an irrational number. So let's see what they have here. They're 2.5, just below 3, just above 3, and just below 5. So some of those we can immediately eliminate. So let's think of the numbers we do know. Let's use 2 and 3. So 2 times 2 times 2. What is that? 2 times 2 is 4, and 4 times 2 is 8. So 2 to the third power is 8. Let's check 3 to the third power. So 3 times 3 times 3. So 3 times 3 is 9, and 9 times 3 is 27. Okay. So this number that we're looking for, right? So radical 8, sorry, not radical 8. The cubic root of 8 is 2. The cubic root of 27 is 3. We're looking for the cubic root of 24. So it's in between 2 and 3. Okay, so we can already cancel that out. We can cancel that out because those are not between 2 and 3. These are both between 2 and 3. Now, this is halfway between 2 and 3. This is really close to 3. Obviously, this is much closer to 24. Sorry, this 24 is much closer to 27 than it is to 8. So it's looking like 2.9 or 2 9/10. Let's just try that. Now, spoiler alert, it is 2.9. Now, you don't have a calculator, so this might be a little, some folks might struggle with this. We're going to plug these numbers in and see which one works, because you can do it this way too. You just plug these numbers in, multiply them by themselves, do this the third power, this the third power, this the third power, this the third power, and see what's closest to that. But without a calculator, some people might struggle with that. So let's try it. So 2.9 times 2.9. Let's see what we get. So 9 times 9 is 81. 9 times 2 is 18, plus 8 is going to be 26. And then 2 times 9 is 18. And 2 times 2 is 4, plus 1 is 5. So already 1, this will be 14, carry the 1, 8. And then 2 decimal spaces, so 8.41. Yep, and then we're going to multiply that by 2.9. So 2.9 times 8.41. 9, and then 4 times 9 is 36. 8 times 9 is 72, plus 3 is 75. And then 2 times 1 is 2, 2 times 4 is 8, 2 times 8 is 16. Add them all together. 9, 8, 13, carry the 1, 14, 24. Okay, so it's going to be 24.389. That's roughly what we get when we multiply. That is what we get when we multiply 2.9 cubed. It's going to be 24.389. So it's quite close to 24. And that's going to be our answer as we kind of estimated. So as long as you know this is in between, that 24 is in between cubic root of 8 and the cubic root of 27, and we know it's much closer to this, then we know it'd be, and we know this is 2 and this is 3. We know it's much closer to 3, but right below 3 There you go. Okay. So that that one's not easy. If you haven't worked with cubic roots, that could be a little confusing. But if you have, it's no big deal, right? All right. Let's see here. Here. All right, number 14. Let's zoom out here so you can see a little better. How much time we got in this period? We got about 20 minutes. That's not bad. All right, which of the following best represents the graph of the equation below? And we have, let me zoom in here so you can see it a little better. We have y equals 1/2 x minus 4. So they put this in slope-intercept form. We have a linear equation. So we have the rate of change, also known as the slope. And here we have the y-intercept, let's see if I can speak today. So we're looking for a line that crosses the y-axis at -4, and it has a positive rate of change where the y value is increasing by 1 and the x value is increasing by 2. So we're going up 1 to the right 2 or down 1 to the left 2. All right, first things first, let's make sure they have the right y-intercept. So which of these have a y-intercept of -4? Now you'll notice these grids have a scale of 2, so each of these boxes represents 2. So it can be a little confusing because some folks would look at this one and they'd count 4 boxes down and they'd say that's the right y-intercept, but it's not because see how it's -8, so this is out. This one is out, it's -8. This one's out, it's 2. This one has to be correct, it's the only one with the y-intercept of 4. Sorry, -4. Okay. So yeah, not a huge fan of that one because it's trying to trick people based on the scale of the graph. Number 15. Okay. What is the value of the expression below? So this is just asking us to know our order of operations, right? Which of course are parentheses, exponents. Then multiplication and division is a single step from left to right, and addition subtraction is a single step from left to right. You'll oftentimes see people write it like this, which drives me absolutely insane because when you look at this, it instinctively makes you want to multiply always before you divide, which is not the case. Multiplication and division is a single step from left to right, so if division happens to be first on the left-hand side before multiplication, the division should be taking place before multiplication. Okay, let's look at this. So parentheses, no. Exponents, yes. 3 squared, that's going to be 9. Minus 16 divided by 4 plus 2. So we got all the exponents, multiplication, division right there. So -16 divided by 4 is going to be -4, so 9 minus 4 plus 2. And also addition subtraction is a single step from left to right, so right now we're just going left to right. So 9 minus 4 is 5, plus 2 is 7. So the answer is 7. Okay. Number 16. The perimeter of a square is 48 inches. What is the area in square inches of the square? So a perimeter, right, it's a square. These are all the same length. It's a square. It's 48. So we all know these are the same. So 4x, because we're going to add them all together, right? X plus x plus x plus x. 4x equals 48. Simply solve for x, right? So divide by 4. X will equal 12 inches. Now make sure here we're saying, oh, hold on. I screwed up. I totally screwed that up. Look, this is what happens when you try to go too fast. What is the area? Always ask yourself what the question's asking us to solve. We're looking for the area, not the length of the side. Wow. That was almost blew that one, guys. Sorry. So what is the area? So we do need to find the length of the side first in order to find the area. So I guess it's not completely bad. So we know this is 12. All right? They're each 12. The area of a square is just the length squared. So what's x squared going to be? The area. So this times this. So 12 squared, the area, and that's going to be 144 square inches. I probably wouldn't have caught my mistake if I hadn't looked at the units, because once I saw square inches, I said, oh, I totally read that way too fast. So that's a good thing to hit upon. Make sure when you're doing this, you are not trying to go too fast like I just did. Okay, read the question a few times. Make sure you understand what is it asking you to find. Identify what it's asking you to find, and then what tools do you need to use to find that target. Okay. Okay. We're going to stop there. I'm going to do a separate video just for the open response. Hopefully that was helpful. All right, thanks for watching, guys.